for this week. In this particular video, what I want to do is go through again residuals, but this time looking at in terms of a residual plot, and to show you what significance a residual plot will have in our regression analysis. The second, what we'll get to after that is after how to find a residual plot, how to interpret one, and a typical question that you might come across for residual plots. Interpreting the plot itself and what it means for our assumption of linearity. I'll do a question there, and then finally we will perform a full regression analysis, which will bring together a lot of the stuff that we've covered this week, including making a scatter plot, finding R, finding the R squared value, interpreting those, looking at what we covered in the last video, which was the Y and the Y-intercept and the slope, and of course the residual plot at the end. Okay, so going back to the beginning here, looking at residual plots. In our last lesson, in our last little video that I left for you, I mentioned that residuals are the actual value minus the predicted value. And we actually calculated some of those just individually. What you can do with your calculator, which is really, really handy, and it's actually essential, is you can obtain a plot that will graph along the EV axis all of the residual values. So I wanted to show you first how we do that. I'm not going to do it on my calculator because I've got the screenshots here, so it should be fairly obvious what I've done. First of all, I've obtained a scatter plot. Obviously, I've put the X and Y values into the listen spreadsheets. I've created the scatter plot with the X, assuming that's the EV, of course, and the Y on the vertical axis. I have then put a line, a regression line, onto that scatter plot. Now, I showed you this in a couple of lessons ago now, how to get the line onto the scatter plot. So that's pressing menu 4, 6, and then 2, and it will put the least squares regression line on the data. The next step to get the residual plot, as you can see, is you press menu, and then you press 4 for analyze, 7 for residuals, and you'll see number 2 there is show the residual plot. Now what you'll see is it pops up underneath. So you have your scatter plot above with the line on it, and then underneath you'll have this thing, the residual plot. Along this axis here is that's your EV axis. So that will line up with the one above it. So that's your x-axis, in other words. On this axis, that's your residual axis. So that's actually how big the residual is. And remember, it will have the same unit as your RV. If you want to know an individual value, all you need to do is scroll over it. So you can see for when X is 2, because you can just move or scroll straight down from 2, and you can see that the residual is negative 2.79. Now the thing about residuals is if your dot, as you can see with this one, just zoom in a little bit, if your dot is below the line, you are going to always get a negative residual. The reason is your actual value is lower than your predicted value. So when you go actual minus predicted, you're always going to get negatives. If your dots are above the line, you're always going to get a positive residual. So for example, that one there that I've just coloured in, that is going to be positive, as is this one over here, always going to be positive. Reason is actual value is higher than the predicted value. You can get residuals of 0. That of course means that the actual value matched the predicted value. Alright, we are going to do it with this one here. We've got some data, X and Y. We'll get that into the calculator, and you'll see the question here has asked us to plot the 2 residuals that are missing. So this one here, we need to know what that is. Wasn't a very good arrow. We need to know what that one is, and we need to know what that one is there. We can actually find it for this one as well when we do the, when we calculate it, when we find the plot. But as you can see, that one is already plotted. So we're going to fill in these blanks, and we're going to plot these 2 residuals that are missing. So you'll need your calculator open for this, and my first step is to get that data into the calculator. Now I have already done it. I'll just go back to where it is. There it is there. And of course I'll just do a quick check that I've entered that in correctly once I find my page. Here it is. Alright, so I've got 1 to 8. Yep, and then I've got, check it. All right, we're good. All right, so like I said before, we want to get a scatter plot to begin with. So data and statistics, and we're putting, as you can see, I've got a lot of stuff in my calculator at the moment, which doesn't make it easy. And just scroll up, and there's, all right, so there, as you can see, is our data. So it's got a bit of a little hump in the middle there. It's a little bit weird, so it's slightly curved, but at the moment we've got fairly linear relationship. Okay, that's besides the point at the moment. Let's get the residual plot. Okay, so menu. We first want to get the line on there, so analyze, and then 6 for regression, and then 2. And you'll see we've got the line. Next step, we go back to menu, back to analyze, which is 4, but this time I'm going to go to number 7, as you can see, is residual, so I'll press 7, and then number 2, show the residual plot. Okay, and there it is straight underneath. Now I mentioned before that we had a little bit of a curve in that residual plot, and you can see that in the scatter plot, and in the residual plot you can see that it's got this bit of a curve happening as well. If we hover over this, as you can see, the dots or the residuals actually popped up. Now we wanted that value. We wanted the residual for when x equals 1. So as you can see, x equals 1 at this point here, and it says it in the coordinate as well. And so the residual is negative 1.33. We just wanted it to one decimal place, so negative 1.3. Go back to here, and we want negative 1.3. We also want to plot that. So if you have a look here, this is going up in 2, so halfway across would be 1. And we're looking at, here's 1 here, negative 1.3. So 1 1/3 roughly. And I'll try and make it about the same size as the dots around it. Oh, there's one of them. I'll go back, and I now want to look at when x is 4 and when x is 8. So along the residual plot, here's where x is 4, so we've got 7.3. And when x is 8, as you can see, we've got 0.1. So 0.1. And what did I say? 7.8, I think. I'll just double check that I got that right. That's 7.3. So 7.3 for the other missing one. And let's plot that as well. So x is 4. I'm going to go up to, so there's 7, 7.4, so nearly halfway. Use a ruler so yours is more accurate. Mine's a little bit of guesswork. So make sure it lines up with the 4 as well. So there's one of the other missing points. The 8 was already there, so I'll leave it as is. So as you can see, if you need to plot a missing residual, you can do it this way. If you don't have the data, you would most likely have to find that residual using the actual minus predicted and then plot it. So that's also possible. All right, I wanted to show you this one because these ones are a classic question that come up time and time again, and I want to show you a strategy for determining the answer. These ones will be multiple choice questions generally, and I'll show you a little trick that I find really helpful. I'll just zoom in on this for a second. So we're nice and close, and I want to remind you that if your dot is above the line, it'll be a positive residual. So this one's going to be positive, so is that one, and that one. If it's below the line, it's going to be negative. So you'll see this one here is negative, and so is that one there. That one there, as you can see, is pretty much on the line. So this is likely to be 0 or close to 0, the residual. So what I'm going to do is see this pattern that's happening from left to right. We are looking for a residual plot that has first a negative, then 2 positives, a negative, 1 close to 0, and then positive, positive. Let's see if we can perhaps rule some out. First of all, this one, you've got a dot right there. So the first residual is positive when we have stated up here that it's negative. So eliminate any that have got the first residual positive. That one does. So B we can eliminate. Looks like D also has the first one positive. So we're left really with E or C. So I mentioned that our pattern, so it's positive, 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 yep. So I mentioned that our pattern should go negative, then positive, and then positive again before going negative. So if you have a look at this one, we go negative, 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 because it's below this 0 here. So E can't be the answer either. Of course, that leaves us with C, but we can just double check. Now, this is very close to the line, so it's hard to tell, but we've got a negative, a positive, very close to the line, but possibly positive, negative, almost 0 again, positive, positive. So just using the negatives and the positives and the ones that are close to 0, we can establish that C is the residual plot for this data. Okay, so what's the point of doing the residual plot? Well, one thing that we need to remember is when we are fitting a line, we are assuming that the data is linear. But sometimes it's hard to see when the data is not linear. And one of the things that we can do is if we create a residual plot, it's actually going to help us work out whether we can confirm, yes, it is linear, or whether we should actually reject it. Because if you find that there's a pattern in your residual plot, so I mentioned this down here, if you find that there is a pattern, what you need to say is that the pattern in the residual plot suggests that a nonlinear model might be more appropriate. Now I find drawing a picture for this is quite handy, so I just might quickly do that now. Say you've got a relationship that looks like this. So it's curving upwards like so. When you place your line through that data, it's going to probably look a little bit like that. Now, if we have a look at this, what would happen when we do a residual plot is we're going to have negative, 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 then positive, 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 positive residuals. So you're going to have on your residual plot all negatives and then positives. Something like that. Now, that's not good. That's a pattern. What we want to see with a residual plot to confirm that it's linear is no clear pattern. So notice this one here. We've got some positives, we've got some negatives, we've got some pretty far from the line, we've got some pretty close from the line. This is what we want. If we are assuming that it's linear, we want to see a residual plot with no pattern. So what we say when we see a random scatter of dots on the residual plot is the following sentence. Our little report. The lack of a clear pattern in the residual plot confirms the assumption of a linear association between the variables, and then you can insert them into the blank spaces there. Like I said, if there's a pattern, so some patterns might look like this, a curve like so, or like the one under here. Alternatively, here you've got a trend. So you can see them in orange, the dots. You've got negatives, you've got positives and then negatives. You've got a trend in the residual plot. So what we want is random scatter of dots. Let's have a look at this one here. Now, what I'm going to have to do is enter this data in because it's using X and Y, and I've already used X and Y in my calculator, so I just need to change what I've done here. So I'll just go back to here and let's enter that data in. So I've got 0, 1, 2, 3, and 10. And just go back to the top and enter from the start. So for the Y, I've got 1, 4, 15, 60, 94, 134, 180, 240, Okay, there we go. All right, hopefully I've entered that in correctly. Now what do I want to do? We want obtain a scatter plot and see if it's appropriate to calculate R and give some reasons. Okay, well we've really done that before, so I might just add my data and statistics. I'll get on here my Y variable, there it is, and over here my X variable. All right, so have a look at it. Would it be appropriate to calculate the correlation coefficient for this data? Well, it doesn't look too linear to me. I don't know what you think, but we've got a bit of an increase happening here, and that little rise becomes steeper and steeper and steeper. So this one isn't looking too good in terms of a linear assumption. So would it be appropriate to calculate the correlation coefficient for this data? Well, I'm thinking no, because one of the assumptions that we have when we calculate R is that the data is linear. And what we can say is the data shows a non-linear association. So we can say the correlation coefficient, which is what we've been asked to calculate, assumes linearity. So we can use that word. It does assume that the data is linear when we actually calculate it. All right. Obtain the residual plot now, so we'll do that. So we need to put the line on first. So analyze regression A plus B. There's the line. As you can see, doesn't fit the data very well, especially if we were to extrapolate on that particular line. It would come out this way, and it looks like our data actually shoots up in a lot more steeper fashion. What I'm going to do now is put the residual plot on, and we're going to see what sort of pattern we get, because I am assuming a pattern is going to emerge here because we don't have a linear relationship. So 7 for residual, so menu 4, 7, and then 2 for the residual plot. And as you can see, a very, very clear pattern. Bit of a parabola happening here. So what I'm going to do now is I'm going to use my little statement that I'll make when the residual plot shows a pattern. So I'll say the residual plot indicates a distinct pattern that is an S. Let's fix that. A distinct pattern suggesting that a nonlinear model could be more appropriate. What would I have done if it didn't show a pattern? Well, it's likely that I would have had a nice linear relationship to start off with, which we didn't have here. If I couldn't see a pattern there, I would of course state this bit here. The lack of a clear pattern confirms the assumption, etc. However, that was not the case with this one. All right, so where are we headed with all of this? What we want to be able to do is perform something called a regression analysis. Now, as you can see, this is going to include some of the things, well, actually all of the things that we've covered in this particular chapter. First of all, whenever you do an analysis, a regression analysis, you're going to construct a scatter plot and you're going to have a look at the association. If it's linear, of course, you would then calculate the correlation coefficient and you'll interpret that. So strength, direction, and form. You'll find the equation of the regression line, and after doing that, you'll interpret the slope and the y-intercept. You'll also find the coefficient of determination, that's r squared, and you will interpret that as well. You may use the regression line to make some predictions. You may also calculate some residuals, but finally you will use a residual plot to test what your assumption of linearity was like. So was it confirmed, or could you in fact deny that assumption by mentioning or stating that there is a pattern in the residual plot. And finally, of course, like we always do, we write reports on our findings. All right, so the one that I'm going to do uses this particular data. As you can see, mean surface temperature and mean duration of warm spell. So which is the EV and which is the RV? In this particular case, it is the surface temperature that is helping to explain the duration of the warm spell. So our EV is the mean surface temperature, and the RV, mean duration of warm spell. Now you'll see our next step is to get a scatter plot. Let's have a look at the data. So I've done this already. I have actually entered it in. Just find it. I'll just go up to this and to there. There's the data there. And of course, like I said, scatter plot. So I put warm spell is our RV, it's on the vertical, temperature on the EV. So it looks fairly linear to me at the moment. So what we'll do is we'll proceed with our regression analysis. All right, draw the scatter plot, done. Calculate the correlation coefficient. We're going to go to two significant figures here and we're going to interpret that. So I'll go back to this page here and we'll do our menu, 4, 1 and 4. In the X list, of course, we are going to put the temperature. I'm going to have to scroll all the way down. There it is. And in the Y list, it was duration of warm spell, which I called warm spell. There we go. All right, R value. There it is there, 0.91 to two significant figures. R equals 0.91. All right, strength, direction, and form. This indicates, so in terms of strength, strong. In terms of direction, it is positive. And in terms of form, it is linear. Always mention those three things when we interpret R. All right, equation of the least squares regression line to two decimal places. Well, I'm going to have warm spell. You can see I've just abbreviated it here, just so we don't have to write it out in full over and over again. Warm spell, so here we go. Two decimal places, so negative 776.93. So that is our y-intercept, A, and B is positive, so 60.26. Now that's to two decimal places, and that's multiplied by the mean temperature, which I'm just going to abbreviate for now. All right, let's interpret that slope. There it is, 60.26. Is it increasing or decreasing? Have a look at the sign. It's positive, so it's increasing. The slope, it estimates the mean duration of the warm spell. So it estimates the RV to increase by the slope value, so 60.26, for each additional, now temperature here is measured in degrees Celsius, so I'm talking about a 1 unit degree Celsius increase in the mean surface temperature. So every time the surface temperature increases by 1 degree Celsius, the mean duration of the warm spell is increased by 60.26. And I'll put a little unit in there because it's in days, I believe. If we just check that, yes, it is in days. So make sure you use the units as well in your slope interpretation. All right, interpret the y-intercept. Well, the y-intercept estimates the mean duration of the warm spell to be, well, the y-intercept is negative 7, what was it? Just have a look. Remember 776.93. So you'll see it's a bit weird because it's negative. That would be because we're extrapolating. When the mean surface temperature is 0 degrees Celsius. So when EV is 0, what is the RV? So here's our rule here. I have just used that particular value there, the A value. Okay. Now we are going to do some predicting. All right, so we have been given here the temperature and we want to find the mean duration. So it was negative 776.93 plus, keep having to go back because I keep forgetting what these are, 60.26. And we're going to get this into the calculator. So 60, and that's multiplied by 13.65. So straight into the calculator with this one. Negative 776. And we get 45 points. What do we want to the nearest day? Okay, so 45.619, therefore 46 days. So if our mean temperature is 13.65, we're expecting, or we're predicting the duration of that warm spell to be 46 days. In this one, this next one, this prediction, the mean surface temperature expected. So this time we're solving for temperature when we want 18 days. So negative 7.693 plus 60.26 by temperature. I'll just call it T and I'll use solve. So menu 3.1. By T, comma T, T equals. And I've got 13.2. And that, of course, is to 3 significant figures. All right, so R squared. We call that the predictive power of the relationship. That's the coefficient of determination. So I would get R squared, of course, from my calculator. I wouldn't just go back to my R value, which I rounded off, and use that. So here it is here. So 0.8288 to 4 significant figures. All right, as a percentage, that would be 82.88%. All right, this tells us that 82.88% of the variation in the RV, which is mean duration of warm spell, is explained by the variation in mean surface temperature. That is the R squared statement that we always make for that particular statistic. So if it asks you to find it and then interpret it, you need to put that second sentence there. Finally, we obtain a residual plot and we interpret it. So I'll go back to my scatter plot. There it is there. I'll put the line on it to begin with. So menu 462. And finally, as you can see, you get the least squares regression line there, which is what we've got already. And check something. Oh, and finally, I just wanted to make sure I remember that. Menu 472 for the residual plot. There it is there. Now, as you can see, we have a random scatter of dots. Now, this is good for our assumption that it was linear. Remember, if there's a pattern, that is a warning bell that maybe you're not working with a linear scatter plot. This one, though, it is random. So what we say is the residual plot shows no clear pattern. Confirming our assumption that the association is linear. So that is a regression analysis. Now, of course, that has been scaffolded, that's been broken down for you. If you were just asked to do a regression analysis, you would need to make sure you did all of these things on this list here. Perhaps not make predictions, because obviously you would need to be given something to make a prediction with, but you could do it. You could just grab you could grab a data value within the data and call that an interpolation. Or an extrapolation even, if you picked one from outside the data. What we need to do to finish off is to fill in the blanks here. So this is the structure I would like you to use. You would always use this structure when you are performing a regression analysis. So what we say is, from the scatter plot, we see that there is a strong, positive, linear. That is what we can see from when we first draw the scatter plot. Association between mean duration of warm spell and mean surface temperature. So we mentioned the two variables that are being plotted together here. And then we write the R value, which I think was 0.91. There are no obvious outliers. If there were, we would mention them. The equation of the least squares regression line is, so we had mean duration of warm spell equals negative, I'm going to have to go back again, 776.93. Oops. There we go. And should have 60.26. Sorry, this is clearly playing up again. Mean temperature, or mean surface temperature. You see this one's a little bit of a mouthful. Just temp will do. All right, so there's our regression line. The slope predicts that on average, the mean duration of warm spell increases by 60.26 with every 1 degree Celsius in temperature. Y-Intercept predicts that on average, the mean duration of warm spell is negative when the mean surface temperature is 0. So as you can see, that's extrapolating, so that's why we've got quite a ridiculous result. The coefficient of determination indicates that, okay, what was our percentage again? It was 80, where is it? Down here, 82.88. So we put that in our report here, 82.88% of the variation in, and this is mean duration of warm spell, the RV, is explained by variation in mean temperature or mean surface temperature. And finally, we mentioned the residual plot. The lack of a clear pattern or a distinct pattern in the residual plot confirms the assumption of linear association between, and finally we'll say the variables, mean duration of warm spell and mean surface temperature. And that is your first regression analysis. As you can see, they are fairly time consuming, so I will give you a selection of these to do. There are quite a lot of questions that you can use to practice. So really, the amount that you do will be up to you. I will give you some as a bare minimum to do, but of course, if you need that extra practice, those questions are there for you to try. So, thank you very much for spending the time to go through this, and I would like you to now try some of those regression analysis questions, please, with the rest of your class time.